In this simulation, we will calculate the moles of gases. In the 19th century, scientists discovered the equal volumes of any gas at the same temperature and pressure contain the same number of moles. So hydrogen gas, for example, oxygen gas and carbon dioxide gas are obviously three different gases, but equal volumes of these gases at the same temperature and pressure contain the same number of moles. We can say that 1 mole of any gas occupies a volume of 24,000 centimeter cubed or 24 decimeter cubed at a temperature of 20 degrees Celsius and a pressure of 1 atmosphere. So 1 mole of chlorine gas, for example, occupies 24,000 centimeter cubed. Therefore, 0.5 moles of chlorine gas occupy 12,000 centimeter cubed, the half of the first volume. 0.25 moles of chlorine gas occupy 6,000 centimeter cubed, which is half of the 12,000 centimeter cubed, and so on. We can describe the relationship between number of moles of a gas and a volume of a gas in this equation. Number of moles of gas equals volume of gas in centimeter cubed over 24,000, or the volume of gas in decimeter cubed over 24. And depending on what is given, whether it's the number of moles or the volume of gas, we rearrange the equation. So assuming that all gases are at 20 degrees Celsius and 1 atmosphere, how many moles are there in 48 decimeter cubed of hydrogen gas? So the volume of hydrogen gas is 48 decimeter cubed. To get the number of moles, we need to divide it by 24 according to the equation. So the correct answer is 2 moles. Now try solving the other two exercises. How many moles are there in 2.4 decimeter cubed of oxygen gas? Excellent, 0.1 moles, because the number of moles of oxygen gas is the volume of oxygen gas, which is 2.4 decimeter cubed, over 24, because the unit here is decimeter cubed, and that's why we choose the denominator to be 24 and not 24,000. The answer is 0.1 moles. The third question. How many moles are there in 12 centimeter cubed of carbon dioxide gas? Excellent! In 12 centimeter cube of carbon dioxide gas, there is 0.0005 moles. We found this number by dividing 12 centimeter cubed, which is the volume of carbon dioxide gas, by 24,000, and we chose the denominator to be 24,000 because the given unit is centimeter cubed and not decimeter cubed. Now let's try finding the volume while the number of moles is given. What volume will be occupied by 2 moles of chlorine gas? Excellent, 48 decimeter cubed. We are trying to find the volume, and the volume is equal to the number of moles of the chlorine gas times 24, that is 2 times 24, giving us 48 decimeter cubed. What volume will be occupied by 0.1 moles of helium gas? Excellent! 2,400 centimeter cubed. We multiplied 0.1 moles times 24,000, giving us 2,400 centimeter cubed, which is the volume occupied by 0.1 moles of helium gas. Once we understand the equation and how to rearrange it, applying it becomes much easier. The third question. What volume will be occupied by 0.02 moles of carbon monoxide gas? Excellent! 480 centimeter cubed is the correct answer. We multiply 0.02 moles by 24,000 because the options are all in centimeter cubed, and the answer is 480 centimeter cubed. Notice that they are different gases. We tackled chlorine gas, helium gas, carbon monoxide gas, and others, all by the same equation.